Assalamu alaikum students. Once again, I welcome you all to my YouTube video class. This class is a continuation of previous session. In today's session, we are going to discuss about Chapter-7, Composition and Decomposition, Part-2. In the previous session, we have learnt notations for algorithm, composition and its types like sequential statement, alternative statement and conditional statement. Now we are going to learn about case analysis, iterative statement and decomposition. Now we are going to start with case analysis. Alternative statement analyzes the problem into two cases. So we have only two blocks. One is true block, another one is false block. If the condition is true, true block will be executed. If the condition is false, the false block will be executed. But in case analysis statement, we have multiple cases, that is multiple blocks will be there. So case analysis statement generalizes it to multiple cases. Case analysis splits the problem into an exhaustive set of disjoint cases. So we have multiple cases in case analysis statement. For each case, the problem is solved independently. Here we have three cases, that is case C1, case C2 and case C3, and we have four statements, that is S1, S2, S3 and S4. In alternative statement, we have two blocks, one is true block and another one is false block. Whereas in the case analysis statement, we can use any number of cases and there is no restrictions here. In our book, they have given only 3 cases, but we can give 5 cases, 10 cases or any number of cases you can give. All cases are declared independently. Here the conditions C1, C2 and C3 are evaluated in turn. First, the condition case C1 is checked. If that evaluates to true, the corresponding statement S1 will be executed. If suppose the case C1 is not satisfied, the control will jump on to the case C2. If it is satisfied, the S2 statements will be executed. Otherwise, it jump on to the case 3. So, it will be goes on like this. If none of the conditions evaluates to true, then the default case, that is last statement, else statement, S4 will be executed. Now, let's see the same example, comparing two values with 3 conditions. If A is lesser than B, then -1 will be the result. If A is equal to B, 0 will be the result. And if A is greater than B, then 1 will be the result. So, these are the conditions here. We have 3 disjoint cases, that is A lesser than B, A is equal to B and A is greater than B. Let's see an algorithm now. Compare A, B. Compare is the name of the algorithm and A, B is the input variables, 2 input variables. Then case A is less than B. For example, A value is 2 and B value is 4. In the first case, it checks the value A is lesser than B, that is 2 is lesser than 4. The condition is true here. So, in the first case itself, the condition is true. So, -1 will be the result. Then, the remaining cases will be skipped. If suppose the value of A is 5 and the value of B is also 5 means, in the first case, it will check A is less than B, that is 5 is less than 5. So, the condition is false here. Now the control will jump to the second case. Here the condition will be checked. A is equal to B, that is 5 is equal to 5. Here the condition is true. So 0 will be the result. So the remaining cases will be skipped. This is how case analysis works. So case analysis is the multiple cases statement based on the condition the control will jump on to any one of the case and the remaining cases will be skipped here. This is how the case analysis works. Next one is iterative statement. An iterative process executes the same action repeatedly. That is called iterative statement. Sometimes we need to execute the same set of statements for a certain number of times based on the condition. For example, the children may go around the ground for some certain number of times. So, moving around the ground is the process. They have to go around the ground 5 times. On the 6th iterative, the program checks the iteration, and after the 5th round is over, the process stops. So, based on the condition, the process repeats a certain number of times. In iterative statement, a condition of the statement is tested, and if the condition is true, a statement is executed. Again, the condition of the statement is tested, and if the condition is true, a statement is executed. So, the same process will be repeated until the condition becomes false. Once the condition false, the loop ends and the control flows to the next statement after the loop. The pseudocode for iterative statement is while C then S. Here C is nothing but the condition and S is a statement, and this statement is called as an iterative statement. First, the control checks the condition whether C is true or false. If the condition C is true, the statement S will be executed. After executing the statement, again it checks the condition. If the condition is true, the statement will be executed. So, the same process will be repeated until the condition made false. The iterative statement is commonly known as a loop. Until C becomes false, the statement S will be executed here. When C becomes false, what will happen? The loop ends and the control flows to the statement next to the iterative statement. Now, let's see the flowchart for iterative control flow. The condition C will be given in a diamond box. Here, the condition C has 2 outgoing arrows. One is true arrow and another one is false arrow. The true arrow points to the statement S. So, if the condition C is true, the statement S will be executed, and again the control flows back to the condition. Here, the condition is tested again. If the condition C is true, the statement S will be executed again. So, the same process will be repeated until the condition becomes false. Once the condition C is false, the loop ends and the control flows to the next box after the loop. So, this is how the iterative statement works. Now, let's see an example. Construct an iterative algorithm to compute the quotient and remainder after dividing an integer A by another integer B. So, we are going to divide a number A and B. Okay. In the previous chapter, already we have discussed that how to write a specification for dividing two numbers. So, now we are going to write the specification of an algorithm. To write a specification, we have to use 3 steps. The first step, we have to mention the name of the algorithm and the input variables. Here, the name of the algorithm is divide and the input variables are A, B. So, A, B should be an integer. Integer is nothing but a whole number without using decimal point. Then we have to mention the input property, double hyphen inputs. A is an integer and B is not equal to 0. That is, dividend should be an integer and the divisor should not be equal to 0. So, numerator be an integer and the denominator should not be equal to 0. And the next step is the property of output and the input-output relation. So, what is the input-output relation here? double hyphen outputs colon Q and R, that is quotient and remainder, such that A is equal to Q into B plus R, that is quotient into divisor plus remainder, we will get the value of a dividend. So A is equal to Q into B plus R. Then 0 is less than or equal to R, then less than B. So the remainder is greater than 0 and less than the divisor. Now we can construct an iterative algorithm that satisfies the specification. Divide of A comma B. Now we are going to declare the value of A is 22 and B is 5. So we are going to divide 22 by 5. Then the input property is double hyphen inputs colon A should be an integer and B is not equal to 0. Then output property, that is double hyphen outputs colon Q and R, that is quotient and remainder, such that E is equal to quotient into divisor plus remainder, that is A is equal to Q into B plus R. Now we are going to multiply quotient into divisor, then we are going to add with the remainder, we will get the result of A, that is dividend. Then 0 is less than or equal to R, then less than B. Then the next step is Q comma R is equal to 0 comma A. So the value of Q, initially the value of Q is 0, quotient is 0 and the remainder value is A. So what is the value of A? 22, because still we didn't divide. So the value of A is 22. Then while R is greater than or equal to B. Here we are going to check the condition. So the loop is while loop. While R is greater than or equal to B. What is the value of R here? 22. The value of R is 22 and the divisor, the value of divisor B is 5. So 22 is greater than or equal to 5. Here the condition is true. If the condition is true, the statement will be executed, that is Q comma R is equal to Q plus 1 comma R minus B. So here the Q value will be incremented as 1 and we are going to subtract divisor from the remainder here. So initial value of A is 22. So initially the value 22 will be stored in the remainder R and the value of B is 5. So 22 minus 5. What is the value? 17. Now let's check the iteration process. Iteration Q, that is quotient, Q plus 1, R, that is remainder, R minus B, then A is the dividend, then B is the divisor. So in the first step, iteration value is 0, then Q value is also 0 initially, then the remainder is 22 because A value is 22, so the remainder is also 22. Then A value is 22 and B value is 5. Here A and B are two input variables that do not change their values throughout the process. Then Q and R are two output variables that change their values in each iteration. In the first iteration, the condition will be checked while R is greater than or equal to B. That is 22 is greater than or equal to 5. Yes, the condition is true. So the control comes to the next statement. Q comma R is equal to Q plus 1 and R minus B. So the Q value will be incremented as 1. The value of Q is 0 initially. So 0 plus 1, the value of Q is 1 currently. Then R minus B. R value is 22, B value is 5. So 22 minus 5 is 17. So the current value of Q is 1 and R is 17. Now the control comes to the condition while R is greater than or equal to B. Now the value of R is 17 and the value of B is 5. So 17 is greater than or equal to 5. Yes, the condition is true. So the Q value will be incremented as 1. The current value of Q is 1. So 1 plus 1 is 2 here. Then R minus B. R value is 17. 17 minus 5 is 12. So the current value of Q is 2 and R is 12. Again, the condition will be checked while 12 is greater than or equal to 5. Yes, the condition is true. Then Q will be incremented as 1. What is the value of Q here? 2. So 2 plus 1 is 3. The value of Q is 3 here. Then R minus B, that is 12 minus 5. 12 minus 5, the value is 7. So the current value of Q is 3 and R is 7. Again the condition will be checked while R is greater than or equal to B. That is 7 is greater than or equal to 5. Yes, the condition is true. So the control comes to the next statement. Q value will be incremented, then R minus B. So Q value is 3. So 3 plus 1 is 4. Then R value is 7. 7 minus 5 is 2 here. Again the condition will be checked while 2 is greater than or equal to B. Here the condition is false, so the loop ends here. So how many times the loop iterated here? 0 to 4 times. At the end of iteration 4, the value of Q is 4 and R is 2. So 2 is greater than or equal to 5. The condition is checked here. Here the condition is false. So the loop stops its execution and the control will come out of the loop. I hope you understood this, right? Next example is chameleons of Chromeland. Already we have discussed this example in chapter 6. Do you remember that? So what is the concept of chameleon of Chromeland? On the island of Chromeland, there are 3 different types of chameleons. Red chameleons, blue chameleons and green chameleons. Whenever 2 chameleons of different colors meet each other, they both change their color to the third one. So, we have to arrange a series of meetings that result in all the chameleons displaying the same color. So, when it possible, suppose the 2 types of chameleons are equal in number. We have a possibility to get all the chameleons in the same color. So, construct an algorithm that arranges meetings between these 2 types so that they change their color to the third type. In the end, all should display the same color. Now, we are going to write the algorithm. Monochromatize of A, B, C. Here, monochromatize is the name of the algorithm and A, B, C are 3 input variables. So, the number of chameleons of each type by variables are A, B, C. And the input property is double hyphen inputs colon A is equal to capital A, B is equal to capital B, C is equal to capital C, E is equal to B. Here the input variables are small a, small b, small c, and the values assigned to these variables are capital A, capital B and capital C. Then small a is equal to small b. Here a and b values should be equal number of chameleons. Then only we can achieve this. So let a is equal to b be the input property here. Then the input and output relation is double hyphen outputs colon A is equal to B is equal to 0. Then C is equal to A plus B plus C. Finally, no chameleons will be in A and B. So, A is equal to B is equal to 0 and all the chameleons will be added in C. So, C is equal to capital A plus capital B plus capital C. So, in each iterative step, 2 chameleons of the 2 types that is equal in number meet and change their color to the third one. For example, A, capital B, capital C is equal to 4, 4, 6. So, first 2 chameleons are equal in number. Then, the series of meetings will result in all the 2 color of chameleons will be changed as third color. Now we are going to check the condition while A is greater than 0. The value of A is 4. So 4 is greater than 0. The condition is true. Now the control will come inside the loop. A, B, C is equal to A minus 1, B minus 1, then C plus 2. So the value of A is 4. Then 4 minus 1 is 3. Then B minus 1, B value is 4. 4 minus 1 is 3. Then C plus 2, C value is 6. So 6 plus 2 is 8 here. Again, the condition is checked here. While 3 is greater than 0. Yes, the condition is true. Now A, B, C. The value of A and B will be decremented by 1 and C will be incremented by 2. So 3 minus 1 is 2. Again 3 minus 1 is 2 and the value of C is 8 now. So 8 plus 2 is 10. Again the condition is checked. So 2 is greater than 0. Yes, the condition is true. Then the same A and B value will be decremented by 1 and C will be incremented by 2. So 2 minus 1 is 1. 2 minus 1 is 1. Then 10 plus 2 is 12. Now again the condition will be checked. 1 is greater than 0. Yes, the condition is true. So A and B value will be decremented by 1. So 1 minus 1 is 0. So the both values are 0 now. And C will be incremented by 2. So 12 plus 2 is 14 now. Then again the condition will be checked. 0 is greater than 0. Now the condition is false. Now the loop ends its execution. Finally, the value of A and B becomes 0 and all the chameleons will be added in C. So, at last we achieved the concept. Assume that in the beginning we have 4 red chameleons, 4 blue chameleons and 6 green chameleons. In the final state we have 14 chameleons in the same type, that is green color. It is possible only first 2 chameleons in the same number. Then only it is possible to achieve this. I hope you understood this, right? Now we are going to discuss about a next topic, that is decomposition. Problem decomposition is one of the elementary problem solving techniques. So this is the technique which is going to reduce the work of the user. It involves breaking down a problem into smaller and more manageable problems and combining the solutions of the smaller problems to solve the original problem. So, if your problem is very smaller in size, then it is very easy to find the solution and we can solve that problem also. In some cases, your problem will be in a bigger size. Okay, in such cases, it is very difficult to find a solution by a single function or a single structure. So, within a single structure, it is very difficult to find the solution for the complex problem. In such cases, we can divide that problem into many subproblems and each subproblems will be perform the particular task and finally will combine all the result and will find the solution for the original problem here. So, this is nothing but decomposition. Do you understand this? The next one is refinement. After decomposing a problem into smaller subproblem, the next step is to refine the subproblems. So what do you mean by refinement? Refinement is nothing but to abstract the subproblem. Then what is abstraction? Abstraction is the process of ignoring or hiding irrelevant details and modeling a problem only by its essential features. So each subproblem can be expanded into more detailed steps. Each step can be further expanded to still finer steps and so on. This is known as refinement. So, it can take only the essential details of the subproblem alone. Then, we can also abstract the subproblem. I already told that we specify each subproblem by its input property and the input-output relation. So, we are going to write the specification format with the help of the input property and the input-output relation. So, while solving the main problem, we only need to know the specification of the subproblems. We do not need to know how the subproblems are solved. It just needs the specification. What are all the inputs given for each subproblems? And how the input and output are related for each subproblem. That is the main things. So, we just need the specification of the subproblem for integrating the output to find the solution to the problem. So, we do not need to know how the subproblems are solved here. So, this is all about refinement. Do you understand this? Our next topic is functions. After an algorithmic problem is decomposed into so many subproblems, we can abstract the subproblems as functions. That is, we can just specify the subproblem with the help of the concept called functions. Already we have learnt about functions in the previous chapter, right? A function is like a subproblem. So, similar to an algorithm, a function is specified with the help of the input property and the desired input-output relation. Look at the diagram. Main algorithm is decomposed into the sub-algorithm. Here, the sub-algorithm is called as a function. So, the main algorithm sends the input to the function. Based on the input, the function performs some action and produces the output to the main algorithm. So, the inputs and outputs are travels between the main algorithm and sub-algorithm here. So, to use a function in the main algorithm, the user need to know only the specification of the function. Here, the user need not to know how the problem is solved. So, the user need to know only the specification of the function. That is, the name of the function, the input property and the input-output relation. So, these are the three things that the user need to know while solving the function. Then the user must ensure that the inputs passed to the function whether will satisfy the specified property or not, and also the user can assume that the outputs from each function by satisfying the input-output relation. So the user of the function need only to know what the function does. The user need not to know how it is done by the function. So, the user of the function need to know only what the function does and not to know how it is done. Because there is no need for the user to know how the function is implemented in order to use it. So, those details are hidden from the user. Now, let's see an example. Consider the problem of testing whether a triangle is right-angled or not. Here we have three sides A, B and C, where C is the longest side. Then the triangle is right-angled. Here we have the Pythagoras formula, that is C square is equal to A square plus B square. So we can take a square as the function. Then the function square of is specified as square of y. Here square is the name of the function and y is the variable, input variable. Then the input property is double hyphen inputs y. So y is the input property here. Then the output property is double hyphen outputs colon y square. We can use this function 3 times to test whether a triangle is right-angled. Let's see an example now. Right-angled of A, B, C. Here the name of the algorithm is right-angled and the input variables are A, B, C. Then the input property is double hyphen inputs colon C is greater than or equal to A, C is greater than or equal to B. Here we are using two input properties. So C must be greater than or equal to A and B. Then the output property is double hyphen outputs colon result is equal to true if C square is equal to A square plus B square. If this condition is true, the result will be true. In case it does not satisfy the property, means C square is equal to A square plus B square is not satisfied, means the result will be false. So, if C value is greater than or equal to A and greater than or equal to B, then it satisfies C square is equal to A square plus B square, means we will get a result as true, so it is a right angle triangle. Otherwise false, then it is not a right angle triangle. So, this is the specification for the right angle triangle. Now, we are going to find a square of 3 variables here. So, how many times a function called here? 3 times a function is called. Square of C. Here, square function is called and it finds the square of C and the function returns the value of C. Then, square of A. Again, the square function is called and now it finds the square of A and the function returns the value of A. Then square b will be called. It finds the square of b and the function returns the value of b. Then the value of square of a and square of b will be added and it will check whether the value of square of c and the added value of square of a and b are equal or not. If it is equal, we will get the result as true, otherwise false here. Do you understand the concept? So, function is nothing but a sub-algorithm or a sub-problem. So, it performs its own task. To perform the task, we have to specify input property and its input-output relation. So, the users of a function need to know only what the function does and not how it is done, because those details are hidden from the users. Students, this lesson ends here. I hope you understood this lesson. And the assignment of this lesson is: why is function an abstraction? How do we refine a statement? And what is case analysis? Students, submit your assignment on time. Thank you for watching this video. We'll see you in the next video class. Assalamu alaikum.